Let's begin. Today's May 19th, 2024, and we're doing the Daily Turing Machine Puzzle. Today's puzzle uses 5 criteria cards, 1, 13, 14, 16, and 19, and uses the green verification cards. Let's go solve. So in our grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and then criteria card C. On the bottom row, we've got criteria card D and criteria card E. Criteria card A will compare the first digit, the triangle, and will let us know whether it should equal to 1 or should the triangle be greater than 1. Criteria card B will compare the second digit and the third digit. Should the square be less than circle? Should they be equal? Or should square be greater than circle? Criteria card C will let us know of the 3 digits, which is the smallest. Should triangle be the smallest? Perhaps it's a square, or maybe even the circle. Criteria card D will look at the 3 digits and let us know if there should be more even digits than odd, or should there be less even than odds. And finally, criteria card E takes the sum of the first 2 digits, the triangle and the square, and compares that sum to the number 6. Should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? Remember, we're looking for a unique 3-digit code that meets all of the following criteria. And we'll begin today's puzzle with the proposal of 314. So I think the first thing I'm going to test is criteria card D. I want to know if there are more evens than odds or vice versa. Okay, so the Turing Machine approves of my proposal. So if I take a look at my proposal of 314, I've got 2 odds to 1 even. And since the Turing Machine approves, we can state that indeed there should be less even than odds. So in my notes for D, I'll write down that even is less than odd. Okay? So that means that either they could all be odd, all 3, or at a minimum 2 odds and 1 even. We just don't know yet. And we really can't eliminate any numbers above. Okay, so let's see, what else could we test? I think I'll test criteria card C and see which is the smallest. Okay, so the Turing Machine responds that it does not agree with my proposal. Again, if I look back at my 3-digit code, 314, the smallest digit I have is the number 1, and that's square. But the Turing Machine says, nope, the smallest is not square. So in my notes, I'm going to write down that either triangle is the smallest or circle is the smallest. So again, either triangle is the smallest or it's circle that's the smallest. Okay, so what that means is that square, the one that failed, cannot possibly be 1, right? We can't expect a square to be 1 since there obviously isn't anything smaller. But other than that, I think that's all we can say. You know, triangle or circle, one or the other could be a 1, right? There's nothing wrong with that. It's just that one of those has to be the absolute smallest. Okay, so we already have that. I'm kind of torn between either B or E to see which of those. I think I'm going to test criteria card E and compare the sum, because that may, if indeed the sum is small, perhaps triangle may be the smallest, since we already have an indication that that may be a possibility. So let's try E. Okay, so the Turing machine approves. If I go back to my proposal, notice that the sum of the first two digits, 3 plus 1 is 4, and that is less than 6. So that's what I'm going to write down in my notes. So that was criteria card E. I'm going to say that triangle plus square needs to be less than 6. Okay, so before we consider this, maybe triangle is the smallest, let's see what we can do and eliminate any possibilities. Since the sum of triangle and square has to be less than 6, that means that neither triangle nor square can be a 5, because 5 plus any other digit will already be 6 or greater. So neither triangle nor square can be a 5. Okay, now obviously triangle can still be the smallest. So let's see, are there any other conclusions we can draw? Triangle could be a 1 plus 4, yep, that's less than 5. Even though square being 2 added to triangle 4, that's a possibility, but we can't eliminate the, well, let's see, can we eliminate the 4? You know what, I think we can eliminate triangle being 4, because 4 plus 2 is 6. Yeah. 4 plus 2 is 6. Yeah, it can't be, yeah, so I think we can eliminate 4 as well. Okay. I did not anticipate that. Okay. And we can't eliminate the square 4 because we could always add it to a 1, and 3 plus 2 is 5. So let's see, anything else? There's nothing that really says triangle and square can't be equal. So 2, 2 could be a possibility, but I think as far as eliminating any numbers, I think that's it. Okay. All right, so let's now consider the criteria cards A and B in order to construct our proposal for the second round. So notice that criteria card A is comparing triangle to 1, or it could be greater than 1. And again, we're kind of constrained to our sum. So let's see, could, and also we're comparing square and circle in criteria card B. So let's see, how can we construct our code here? So if circle happens to be the smallest, and that would be, I think if circle could be the smallest, I don't think it could be even 2, because that would force triangle. Well, again, no, we there's nothing that says we can't have duplicates, so I guess technically it could be a 2 for, well, no, actually, no, I take that back. Yeah, it's forced, if circle is smallest, the smallest triangle could be is a 3, and then, of course, a square could also be a 3, and so that couldn't happen, because you get 3 and 3, that gives you 6. So let's see. So if triangle is the smallest, again, somehow A and B together with the other criteria cards are going to be, forcing each other to conform. So I'm trying to think of what we could do. So what could we say about square and circle? Well, wow. Yeah, I think I'm just going to have to try something out. Well, if triangle is a 2, and I have to have a sum that's less than 6, that would mean, well, I still have 2 possibilities. 2, 2. Wow, I'm really kind of torn here about what to do. Okay, so we do know that we need more odds than evens, so that should help us out. Let's see. Wow. Okay. Let me pick three. If I do 3, 2, then that would force the circle to be the smallest. Well, no. Well, I say it has to be the smallest because if triangle were 3, then I could only add a square 2 to have less than 6, and then square isn't the smallest, so that means circle cannot be 3, 4, 5, nor 2, so it would force it to be a 1. Let's try that. 3, 2, 1. Okay, so first, since we haven't tested, let's go ahead and test criteria card A. Okay, so the Turing machine disagrees. That means that A, if I look at my proposal of the number 3, 3 is greater than 1. It does not approve that. So basically it's telling me that triangle should equal to 1. Okay. So I'm going to write down in my notes, triangle is equal to 1. And so let me eliminate all the other possibilities. Alright, so it is equal to 1. So that means that by default, triangle has to be the smallest. So let me go ahead here and cross this out. So triangle is the smallest. Triangle is an odd. And so the possibility, that means really square could be anything. All of these work, 1 plus all these squared digits will add up to be less than 6, so I can't really eliminate anything there. I could eliminate the circle 1, right, because obviously it can't be the smallest anymore. And So yeah, so now let's compare or test criteria card B. Okay, it also disapproves of that. Notice that in my proposal, I have square being greater than circle. So that means that it's either square is either equal to circle or less than circle. So let me write that down in my notes. So square needs to be less than or equal to circle. Okay, so square needs to be either less than or equal to circle. So let's see. We do have one more test, and I guess technically the only one. Well, actually, no, we already kind of definitively know that the sum has to be less than 6. There has to be more odds than evens, and we already established that triangle is smallest. Okay, so let's see. Okay, yeah, so if square has to be, let's see, smaller than or equal, yeah, I don't think we can really eliminate anything. Wow. So let's see. Well, if it were to be equal, I think all of them would work, right? So 2 equals 2. Oh, okay. So it can't be, let's see. Can it be equal? It could be equal, except not 2, 2 or 4, 4. So how do we eliminate those? Can we just outright eliminate them? Okay, right, yes, yeah, of course, since there are, well, no, more odds than evens. Yeah, I think we can just simply eliminate them. Even though we do have this one odd as triangle, I don't think, yeah, but no, I don't think we can just arbitrarily eliminate them, because one could be even and the other odd, and we'd still be okay with criteria card D. So if they are equal, then we only have one possibility, and that's 3, 3. So that could work. What about if square were less than circle? So it would be 2, 3, which is okay, 3, 4, 4, 5. Yeah, I'm thinking that maybe I can deduce that they have to be equal, because there are just so many possibilities for square to be less than circle, right? 2, 3 would work, 2, 5 would work, and then 3, 4 would work, and 4, 5 would work. But there's only one possibility where they're equal, and we have the 2 odds. But unfortunately, I can't test B twice in one turn. So let me think through that one more time. If it's less than, there's really no way to distinguish between all those possibilities. Yeah, you could have 2, 3, 2, 5, and then 3, 4, 3, 5, and even 4, 5. But again, for equal, yeah. So I'm gonna say I'm gonna deduce that square has to be equal to circle, and the only possibility would be 133. So I'm only write down my code here, 133. And that's because I'm deducing that that's the only unique possibility. So let's go test this code at turingmachine.info. So 133. Yeah, it worked out. Okay, so our, somewhat logical yet kind of risk paid off. So let's actually go see how we did versus the Turing machine. Okay, so in the first round we tested CDE. And in the second round, I believe it was A and B, and both of those were incorrect. Okay, so we beat the Turing machine by one question today. So it's a great win. Again, the idea is that you want to kind of talk through some of these possibilities and kind of logically deduce. Like I said, there are too many possibilities where square could be less than circle, and there really was no way to distinguish all of those possibilities. So the only one that kind of was left to pick was that they were equal, and of course we couldn't pick the two evens, and we couldn't twos or fours, and of course the 5 wasn't paired up anymore, so that left us with 3 and 3, and that was again that one unique combination of numbers that fit the fit this puzzle. Okay, well, this was very enjoyable. Please leave any comments. What do you think about the channel? If you like, please give it a thumbs up so that others can find other videos. And if you don't want to miss the next video, please subscribe to be notified. Until next time, have a great one.